This key begins with number 6, and from 6 through 13 they're solving quadratic equations. As you can see, each of them we've got using factoring here, using the square root method, two different options to be able to solve that particular problem. All the others factoring, remember factoring is our favorite way. This last one though, 13, doesn't factor, so you have to use the quadratic formula. Remember to write it as your solutions as two separate solutions. So let's go ahead and look at number 14. For number 14, you've got your quadratic here. We're looking at whether it is facing up or down, the vertex, all of that you know how to do. To find those intercepts, set it equal to 0 and then name them as points. Domain is all real numbers. For range, remember the y values. You can look at the curve, or because this is facing up and the y value of the vertex is negative 25/4, it's everything from there and larger, then increasing and decreasing. For number 15, number 15, given this quadratic, determine whether it has a max or min. We know that it faces up, so we have a minimum. It occurs at the vertex. Find the x value using that negative b/2a. Substitute that in to get the y value. Sure, it's ugly, who cares? But it's a minimum of that y value that occurs at that given x value. 16, you'll see in a minute, is a lot bigger. I tried to squeeze it in there. It doesn't fit. So let's go on to 17. What's the vertex? Again, we use negative b/2a. Find that x coordinate, substitute it in to find the y, and that gives you that vertex. Then to find, for part B, algebraically find the x-intercepts, mean you can't use your graphing calculator, set y equal to 0, solve it by factoring, and you get those x-intercepts. For me, I am okay if you have x-intercepts either as points like this or here as those x values, but remember for the gateway, MyLabs Plus, you're going to have to be more specific in what they're asking you, write it the way they say. For number 18, find the dimensions of a rectangle whose perimeter is 26 and area is 40. That gives you two equations. Take the one, solve it for one variable, substitute it into the other. That's going to give you a quadratic. Solve that quadratic by factoring. When you back substitute, you find that you get this solution. Let's go ahead and look at 16. For 16, you've got the vertex, we know, is 1. For the x-coordinates, set that equal to negative b/2a. Once you find that, substitute that in for the b of this function that they're giving you, the basic quadratic standard form function. And so b is negative 2a. Then use one of the points. I used 1, 3 first and found each of the x's is 1, substituted in here. The y is 3, that's the f of x. And when you're done, you get c equals some expression of a. So for c, substitute in. So now we've got something just with a's. So we use the other point. If you use the 1, 3 again, you're going to get just an equation that's true. You're not going to be able to solve for a. And so instead, use the other point, negative 1 for each of the x's, negative 8 for that y, and then solve for a. Once you have the a, you back substitute, and in doing that, you put it back into what we found for b, and you get this fraction, and then substitute it back in for what you got to c and get that fraction. So you're really just using each piece of the puzzle along the way, and then once you find one of the variables, you go back out again. It is okay if you use negative 1, 8 here, negative 8 there, and 1, 3 here, so switch these two, but either way you get the exact same answer. For number 19, this question is giving us the daily revenue. Number 19, they're giving us these first two equations, the revenue and the cost functions, and how many boxes to maximize revenue. So we know it's a quadratic, so the max and mins always occur at the vertex. This is a quadratic that's facing down, so that means we're going to have a maximum which occurs at the vertex. And we want to know how many boxes of candy, so that's the x-coordinate, so do what we've been doing all along. You do need to have an exact number of boxes, so you're going to have to round this using your rounding techniques to get 119. Then, what is the maximum revenue? That would be the y value of the vertex, but because we've rounded this, we've got to use that 119 to get the max revenue, and that gives us this by substituting it back in. We know profit is revenue minus cost, so actually take the revenue function and subtract the cost function from it. Don't forget to use parentheses around the cost. One of the most common errors is to forget to distribute that negative sign into that second term. So go ahead and distribute that in, and this gives you this profit function. How many boxes of candy must the firm sell to maximize profit? Well, we know it's a quadratic, which is a parabola. It's facing down because this is negative, which means we get a vertex maximum. And so we need the max. We're going to use the x-coordinate. And again, we're going to round, so we get 103 boxes for this one. What's the maximum profit? Put that 103 back into the profit function to be able to get then that value. For number 20, the annual, they give you fixed and variable costs for owning a car and driving it so many miles. So we know variable plus fixed cost. They're telling us 25 cents a mile, so 0.25x, where x is the number of miles. And then the fixed costs are $14.59. Go ahead and substitute in the x, the miles driven here, and so 0.25 times 15,000. Go ahead and you get 5209. Now last year Sally drove her car 15,000. That was B. So then we're done that one. Number 21. Sorry. Electricity is measured in kilowatt hours. For this guy, we've got 3.13 hours a day. We have a 100-watt bulb, and it's 30 days. The day units divide out, and you get watt hours. And so when you multiply them together, you get 9390 watt hours. Convert that to kilowatt hours. Remember, you get 1,000 watts as 1 kilowatt. And so we can make this then 9.39. For the second part, they want to know how much money you save if you replace these bulbs. This is how much money, how many hours we have right now. Because it's not how much money, it's how many kilowatts, sorry. So this is what we're using right now. So instead we put the 26, that's what we're going to subtract off. And the difference between these two is going to be the amount you're saved. And so go ahead and calculate that out. Watch the units on this one. That's where most of the error is going to occur, is in that unit. For the next one, 22, we are going to have to refer back for part C back to 21. But let's start with A. They tell you fixed and variable costs, and that gives us our function. And he used 650 kilowatt hours last month, so we're going to go ahead and put that 650 in for K, the number of kilowatt hours, and that's going to give you this bill that he needs. For C, he's going to change out those kilowatts, and this you refer back to the last problem. Remember, by switching 20 bulbs that were 100 and switch them for 26, if you're using them just 3.13 hours a day, you save this many kilowatt hours in a month at 0.0975 or 9.75 cents per kilowatt hour. You can multiply these two numbers together to see how much you save. This is very interesting. If you only use those light bulbs for 3.13 hours, you're only saving 68 cents a month. And so either you use them more, and that saves you money, or dang, it's going to take a long time to pay off those CFL bulbs. And remember, this is just a mock modeling problem. This is not a true problem. The reality is you save more than that when you buy CFLs. Go down to number 23. For number 23, you get two different scenarios. 913 text gives you 6742 for your bill. The next month, 819 text, 7490. So you're going to make two ordered pairs, where the ordered pairs are the number of texts and then how much money. Now notice that the more texts that are sent, so more texts are sent here, they actually are spending less money. So A, find the linear model. You need slope. We got 2 points, so find that slope. And then I use this point slope formula to find my equation, and dang, it's ugly with fractions, but run the fractions. As soon as you start estimating by rounding with decimals, you're going to come up with a different number when you get down here, so be careful of those rounding errors. For B, it's 1,000 texts for the month, so you just substitute that in and calculate. Find the p-intercept. For us, remember, this model is P of T, where P is the amount you're paying, T is the number of texts that you have. And so what's the intercept? The p-intercept is going to be when x is 0. Set x equal to 0. That gives you 140.07. That is the y-intercept that you're looking for. That's why you set the other one equal to 0. And so what happens when you are sending 0 text? The minimum cost is 140.07. So again, this would be a texter's dream, Bill, because the more texts you send, the less money that you're paying. And for number 24, an immunization advocacy estimates 5 million is spent on awareness campaigns. The mortality rate for pertussis is 0.5%. So this first ordered pair is 5 million, 0.5%. Convert that 0.5% to 0.005. You don't want this percentage sign running through, rampant through your equations. The next one, if 10 million is spent, the mortality rate goes down to 0.3%. So 0.3% gives you 0.003. Now the slope then, you have 2 ordered pairs, find the slope, find the model. Don't forget to rename it. Now for this, it says a linear model rate from pertussis M as a function of the money spent. Function of the money spent means that A is the variable, M is the name of it. So the mortality rate is based on A, the value that you're spending on your awareness campaign. You want to find the M-intercept. You're trying to find the M-intercept. Remember, our ordered pair is amount spent, M rate. M-intercept, you set the opposite one equal to 0, so set A equal to 0. M of 0 gives you 0.007 or 0.7%. So when you spend 0, which is the amount, on the awareness campaign, the mortality rate is 0.7%. Find the A-intercept, and the A-intercept, that's the x value for us. We set the other one equal to 0, so set m equal to 0. The m is the y. So we set the function equal to 0, solve for the a, and get 17.5. So this ordered pair then is 17.5 comma 0. What does that mean? It means when you spend $17.5 million, the mortality rate from pertussis is 0%. So that's it. Hope you're having a great evening.